Hello chemistry students. Today I'm going to walk you through how to make precise measurements in chemistry lab. We're going to be looking at this handout that you should have received in class. At the top it says precision in measurements is vital in chemistry lab. Precision is determined by the number of digits in a measurement. The more digits there are, the more precise it is. What we mean by digits is literally how many numbers are in a measurement, specifically numbers after the decimal place. So let's zoom in a little bit and let's take a look at, oops, it's a little far. There we go. Let's take a look at these two balances right here. Okay. It asks which balance is more precise and why. So let's take a look at this one over here. If we look carefully, there are two decimal places after, there are two numbers after the decimal point. On this balance, there's only one digit after the decimal point. Therefore, we can assume that, or we know that the balance on the left is more precise because there are more digits after the decimal. On electronic equipment, it's very easy to count the number of digits, but one thing you do need to be aware of is that even zeros are going to be important. So whenever you're using digital equipment, you want to make sure that you record every single number that is shown on that piece of equipment. For example, if you look at this balance here, it reads 501.0. If you are recording this in lab, you don't want to just put 501 because that's not showing the precision of the equipment. You want to also record the 0.0. because that 0.0 tells you that it's more precise. Because there's another place after the decimal, this is more precise than before when we just had 501. So there's one place after the decimal. This next example uses pH meters. I would like you to pause this video for a moment and work on this one on your own. When you are ready, hit play again on the video and I will show you the correct answer. So hit pause. Alright, let's take a look at these two pH meters. Let's start with this one on the left. When we read the pH, we want to write exactly what it shows because it's a piece of digital equipment. And we're going to record 4.00. And it has two places after the decimal. This pH meter on this side has 4.0. There is only one place after the decimal. Now that we've recorded our numbers and compared the number of digits after the decimal, we know that the pH meter on the left is more precise because there are more digits after the decimal. Like I said before, when you have digital equipment like a balance or a pH meter, it's very simple to figure out the precision. It gets a little bit trickier when you have non-digital equipment such as a graduated cylinder, a thermometer, a ruler. When you have those types of pieces of equipment, you still need to be aware of how precise your measurement is. You will need to go one place past the number you know for sure. You're going to write all the numbers you can read on the equipment and estimate one more digit. Before we do our measurements, we have to figure out the scale of the equipment. What this word scale means is that it's going to tell you how much each line on the equipment is worth. We know that a ruler or a thermometer has many lines that don't necessarily have a number next to it. We need to figure out how much each line is worth. For example, on a ruler, if you have a ruler that doesn't have very many lines, each line may only represent 0.25 inches. If there are more lines, each line may represent 0.125 inches. It all depends on the type of ruler that you have. So in order to find the scale of the equipment, you're going to have to use a little bit of trial and error. I would first try counting by fives and see if that makes sense on the equipment. See if each line is worth 1, see if that makes sense, and then count by 0.5s, then 0.25. So try to figure out the scale that's being used. Alright, let's flip our paper over and we're going to start at the top. We're going to look at this example that's already been done for us with a thermometer. So the first step they did is figure out the scale of the equipment. So if you look at this thermometer, it labels 80 very clearly for you here, and 90 is clearly labeled. And it looks like it also marks sort of a halfway point, but it doesn't have a number, but we know that this is halfway between 80 and 90. So what I need to do is figure out how much each line is worth. Okay? It tells me that the scale is 1. So let's double check and make sure that makes sense. So this big line is 80. This would be 81, 82, 83, 84, 85. That makes sense. 85 is halfway between 80 and 90. 86, 87, 88, 89, 90. So a scale of 1 works perfectly. That means each line represents 1 degree on this thermometer. The second step is to read the numbers you know for sure by looking at the instrument. If we look, we know for sure that it is past 85, and it actually goes 2 more lines above that. So we for sure can read the instrument as an 87. The third step is to estimate your next digit. So you're going to go 1 place past what we know, what we did in number 2, and estimate 1 more digit. If you look carefully, you notice that this line is halfway between 87 and 88. So they estimated the digit as being a 5 to represent half. So our final measurement on that thermometer would be 87.5. Let's go down and do one more example. Let's do this example with a graduated cylinder. What you need to know about measuring on a graduated cylinder is that it is going to have a curve when you measure water. This curve is called a meniscus. When you have a meniscus, you always want to measure from the bottom of it, not the very top here. You always want to measure from the bottom of the meniscus. So our first step is to figure out the scale. So if you look carefully at this graduated cylinder, this large line here represents 6. This large line represents 8, and we have a halfway point here that's not marked, but we can assume that that is 7. So we need to figure out what each line in between is worth. 1 was our scale for our thermometer that we just did, but that won't work on this graduated cylinder. It's obviously divided up into smaller portions. So we have to use a little trial and error. So let's try counting up by 0.25. So that would be 6, 6.25, 6.5, 6.75, and 7. That doesn't quite work. So let's try something a little bit smaller. So let's try by 0.2. So this would be 6.2, 6.4, 6.6, 6.8, 7. That works perfect. So the scale of this instrument is 0.2. That means each line on the graduated cylinder shows 0.2 milliliters. Our second step is to read the instrument, the number that we know for sure based on what the instrument is showing. So we're measuring from the bottom of the meniscus again. So here's 6. Each line is worth 0.2, so we have 6.2, 6.4, 6.6. It hasn't reached 6.8 yet, so we're going to record it as 6.6. Now, because this is not a piece of digital equipment, we have to estimate 1 additional digit. So we're going to look at where this line falls compared to the next line. If you look, 6.6 is pretty much right on that spot. It's not even halfway between. So I'm going to estimate my next digit as being a 0. I still have to add that 0 because it tells me that my measurement is more precise. I don't want to just leave it as 6.6. I have to add that 0 saying I estimated the next digit and it looked like it was exactly 6.6. Alright, so what I would like you guys to do is go back and do this on this number 1 with the thermometer and the one on the bottom here with the ruler. And the answers will be on eClass, so double check your answers and we will review this some more in class later.